In Lesson 14, we'll be continuing our work with fractions. We'll be working with exponents. We'll be doing problems in which our fractions are raised to powers. We'll also be using our rule for the order of operations to help us work problems that involve fractions and more than one operation, and also fractions involved with parentheses and exponents. Remember, as you're watching the tape, take careful notes. If I cover a concept or do a problem that you don't understand, stop the tape and get some help. We will begin by raising fractions to a power. If we look at the expression a over b raised to the nth power, our n is our exponent, and our a over b, or our fraction, is our base. So what this means is that our fraction, or our a over b, will be a factor n times. Whatever the exponent is, we will use a over b as a factor that many times. So now let's raise a fraction to a power. In this case, our base is our fraction, 3/5. Our power, our exponent, is 3. The 3 tells us that 3/5 is going to be a factor 3 times. So let's write 3/5 as a factor 3 times 3/5 times 3/5 times 3/5. To multiply, we look and see if we can reduce, and of course here we can't, so we multiply numerator by numerator by numerator. 3 times 3 is 9, times 3 is 27. 5 times 5 is 25, times another 5 is 125. So 3/5 raised to the third power is 27 1/25. Another way to have gotten this answer would have just to have raised each part of your fraction to the power. Raise 3 to the third power and get 27. Raise the denominator 5 to the third power and get 125. That would be another way to get our answer. Let's look at a mixed number being raised to a power. Let's raise 2 4/5 to the second power, or we can say let's square 2 4/5. In order to raise a mixed number to a power, we've got to do the same thing that we normally do when we multiply mixed numbers. In other words, this really means 2 4/5 multiplied by 2 4/5. Well, the way we multiply 2 4/5 by itself is we change them to improper fractions. 5 times 2 is 10, plus 4 would be 14/5, times another 14/5. So now we're ready to multiply 14 by 14, and when we do that, we'll get 196. I'll just go ahead and tell you that. And 5 times 5 will give us 25. It's 5 to leave our answer as an improper fraction, since nothing could be reduced here. But if we prefer to make it a mixed number, we can. So let's come over here and divide 196 by 25 and see what our mixed number would end up being. 25 will go into 196 7 times. 7 times 5 is 35, and carry our 3. 14 and 3 is 17. And when we subtract, we get 21. So our mixed number is 7 wholes and 21 25ths. So an acceptable answer would either be 196 25ths or 7 and 21 25ths. I would like for you to do some practice problems that involve raising fractions and mixed numbers to powers. The first problem is 1/8 raised to the second power, or 1/8 squared. The first one. The second problem is 1 3/4 cubed, or 1 3/4 raised to the third power. Once you've copied these problems down, cut off the tape and work the problems. When you get them worked, cut the tape back on to check your answers. The practice problem answers are number 1, 1/64, number 2, 343/64, or if you want to make it a mixed number, you would have 5 and 23/64. If you disagree with one of these answers, you need to stop the tape and find a tutor or an instructor to look at your problem and see what you've done wrong. The next thing we want to work with is using our rule for order of operations with fractions. We want to make sure we know what to do when we have more than one operation in a problem, or when we have parentheses or exponents. Our rule for the order of operations will be exactly the same as our rule was with whole numbers. As you remember, our first step is always to work inside symbols of inclusion. Your symbols of inclusion are things like parentheses, brackets, or braces, and you work from the inside out. If you have more than one symbol of inclusion in a problem, you go as far in as you can and then work from the inside out. The second thing we did after we worked within our symbols of inclusion was to work with exponents. So our second step is to evaluate exponents. After working with exponents, as you remember, our third rule was to multiply and divide from left to right. And then finally, our fourth step was to add and subtract from left to right. So these are the 4 rules we're going to follow, the order in which we're going to follow to work with problems that involve several operations. So let's try some problems. I want us to try 2 different problems that have the same numbers in them, but are worked differently because they have different operations. Notice the first problem is 20 minus 15 times a third, and the second problem is 20 minus 15 plus a third. So I would like you to see how we're going to approach these differently. To begin the first one, since we don't have any parentheses or exponents, we can skip our first 2 steps for our rules for order and begin with our third step that says to multiply or divide from left to right. So we need to do this multiplication first that's over here. 15 times the 1/3. So when we begin the problem, we would write our 20 and our minus down, and then we'd write our answer to what 15 times a third is. And since I didn't leave myself too much room, I'm going to come over here to the side and do 15 times a third. Remember, when you multiply, you want everything to look like a fraction. And you want to reduce if you can. 3 will go into 3 1 time, 3 will go into 15 5 times, and we're left with 5 over 1. Now, we'd want to go ahead and change that 5 over 1 into a 5, because that's what 5 over 1 is. we come back over here and fill in an answer of 5, because 15 times 1/3 is 5. Then we go back and finish our problem, 20 minus 5, and that would give us 15. So our answer to that first problem would be 15.